Greetings fixers! Today we're going to be looking at what has to be the cheapest flash cart ever invented for the Atari 8-bit line of computers. We're going to build it, 3D print a case and test it out. And we're going to do it right now. Mark Fixes Stuff. This channel is sponsored by PCBWay, and they don't just do PCBs. If you want professional 3D printing, just upload your models, pick from a variety of materials and colours, and you're on your PCBWay. Thanks to Elaine and the PCBWay team for supporting Mark Fixes Stuff. So first things first, we need a PCB. The A8PicoCart board is by Robin H. Edwards, and he's kindly uploaded it to his GitHub. I'll tell you how to order your own from our video sponsor PCBWay in a moment. We'll also need a Pi Pico clone. This is not a standard Raspberry Pi Pico. In fact, it's often labelled as a Purple Pico or a Raspberry Pi 16 meg Ultimate version. And the last thing that we need, well, we don't need it because it's optional, is a reset switch. These are tactile push-to-make switches. They're fairly standard stuff, and I've got a variety of lengths of shaft here. I've left links below for this set of switches and also for the Purple Pi Pico. To get your board, I'll show you how from our sponsors PCBWay. On their ordering page, we're simply going to click Quick Order PCB. Just ignore all of the pricing details on the right hand side until we've selected all of our PCB's options. First, we need to upload our Gerber file. A Gerber file contains all the information about the PCB, and Robin has kindly left this freely available on his GitHub page. Link below. When the Gerbers have uploaded, you'll get a rudimentary representation of how the PCBs will look. Most of the other options can be left as default. However, we will need to select the option to add an edge connector. And this is where most people abort the process, because when we click yes, the price rockets up to almost $300. Ouch, but don't worry because we'll bring that right back down in a moment. To make it easier to push our card into the slot, we're going to select 45-degree beveling. When you select edge connector, the default option is hard gold. This is very pricey, too pricey for a project like ours, so I suggest that you go with an HASL option. Hot air solder leveling is the way to go. And I notice I accidentally selected the one with lead, but lead free is the same price. Now we're down to $25.43. So let's change some of the options here for delivery. First of all, I'm in the United Kingdom. There's a pop-up about tax responsibilities, and because I'm not in a hurry, I'm going to select 7 to 9 business days to bring my price down to under $10. Job done. Now let's build this thing. We're literally going to mount our Pi Pico on top of this board using the header pins provided. How easy is that? Well, actually the bag's a bit tough for a weakling like me, but eventually I get it open. These Purple Pi Pico clones are a little bit different to the normal Pi Pico. This project is not compatible with the official green Raspberry Pi Pico board. While the official board has the same number of physical pins and fits in the PCB, its pin functions differ. Using it could damage the Pico or your Atari, so instead use one of the 16 meg Purple clones, which are actually cheaper and have more usable GPIO pins, which are necessary for our cartridge port emulation. It's time to solder. Using my trusty soldering stand, I get ready to mount the Pico board in its grips. You might notice that I've put the board in slightly offset. That's just so I can fit the row of header pins in without the grips being in the way. As soon as I turn this board over to start soldering, the row of pins is going to drop out, so I'm just going to stick a bit of blue tack on the side and on the inside as well. Time for some hot tool action. And then it's time to grab my roll of solder and my solder tip cleaner. I've always favoured a brass wire tip cleaner over a wet sponge because, well, to my mind, it doesn't lower the tip temperature. And speaking of which, we're going to be at 330 degrees centigrade. That's my kind of go-to temperature for soldering boards and projects like this. And because I don't know where these boards or pins have been, I'm going to hit them initially with a little bit of Topnic RF800 flux. This might be overkill, but as this flux cleaner burns off, it will remove any impurities on the pins or the pads themselves. Try to heat the pin and the pad at the same time. This will cause the solder to flow into the gap between the pin and the pad, creating a conical shape, sometimes known as the volcano. This is a good solder joint, but I've added too much solder. Even reflowing it won't cause it to run into the gap, but it's fine. On this joint, I think I applied the solder a little bit too early and it didn't flow into the gap properly. Because this is just a pin and a pad though, I can reflow it and allow that solder joint to set properly. With the two ends secured, we can remove our Smurf poo. If it doesn't come off at first, you can just dab with your main blob and that will pull the rest away. I could go ahead and solder the rest of these pins, but that might make it difficult to insert into the main PCB when we're finished. So what we're going to do is tack the other row of header pins into the other side, insert them into the PCB, and then do everything when it's in place. Some more of the blue goo. But it's not always effective. As we can see, this row of header pins is a little bit bent. This end is fine though, so let's solder this one into position. For the other end, we need a bit more tension to cinch the pins into the board. Let's remove the blue tack, it's not doing a good job here. Don't worry though, I have a plan. Ta-da-da-da! Captain Tape, with its ability to withstand high temperatures. And although at this point I'm just wrapping it around in the hope that it holds it into the board enough for me to solder these pins. I think that's close enough. We don't need to be super accurate here. I certainly don't want to hold it into the board as I'm soldering it. If the pins are slightly proud, I suppose I can just trim them down later. To film this side of the board, I'm working at arm's length around the camera, and that results in what I can only describe as a shamefully awful solder joint. I reflow this one as well until it's acceptable. With both ends of the row of header pins soldered into position, at least well enough for my needs, we can remove the Raspberry Pi Pico 16MB Ultimate clone from the PCB holder. And as I said, we need to solder all the rest of the pins. But as I said before, I've soldered header pins onto Pis before and then tried to put them into PCBs, and any slight angle on those pins can make it difficult to get it into the PCB. This board can be a bit confusing, so take note of where pin 18 needs to go, and then look on your Raspberry Pi Pico, and you'll see that pin 18 is also labelled there. If they're both matched up, you won't have any problems. Even without the pins being soldered, it was a bit of a struggle to get the pins through the board. I'm glad I didn't solder them now. Let's get the rest of the soldering done on the top side of the Pi Pico. And a note for the curious, you don't need this 4-pin header, so you can pop this into your parts bin. I will be filming all the soldering today. Some of it will be sped up, but I want to ensure that anybody can follow along with this at home. Robin has tailored the firmware for the Purple Pico clones with a USB-C connector, 16MB of flash and a single boot cell button. These little wonders might come with either WinBond or the more leisurely Z-bit SPI flash chips, but don't worry, his firmware gets along with both of them. Just beware that you might receive a device with a mystery flash chip that hasn't been tested. It's a bit like a box of chocolates. You never know what you're going to get. That's one side of the top side done, let's do the other side. Robin has hooked us up with everything we need to bring this project to life on his GitHub. If coding is your thing, all his source code is available for your tinkering pleasure. There's even a fairly comprehensive manual that spills all the secrets of the cartridge's superpowers. As usual with my videos, I am standing on the shoulders of giants. This is such a great project, and the fact that it's available for free, well, it blows my mind. If you build an A8PicoCart, perhaps think about tossing a coin or two in Robin's direction to help fund this project and his future endeavours. The top rows are now both soldered. Removing our cartridge PCB gently from our holder, we'll of course need to flip it over because we've got the same amount of pins to solder on the bottom side. I appreciate that not everybody's into gratuitous soldering shots, so I'll try to speed this up a bit. I really love to know what people think of my videos, so if you're building this and following along, then please leave a comment below and let me know how you're getting on. When I started out soldering, we didn't have things like YouTube. In fact, we only had 3 television channels. The greengrocers shut half day on Wednesday, and the internet as we know it today was just a futuristic sci-fi dream. It occurred to me when I was soldering these pins that you don't really need to solder the Pi to the board in order to test the firmware. So it might be worth actually doing that before you go to all this soldering hassle. You know, just in case the Pi Pico clone doesn't work. And yes, that is a bit wonky, but it's close enough for jazz. And that's the Pico soldered in. Now we need a reset switch, and counterintuitively it's mounted on the opposite side of the board to the Pi clone. We're going to be 3D printing a case for this cartridge later in the video, so I'm selecting this switch for our board, which has a 9mm shaft and should be long enough to protrude outside of any casing that we make. The nice thing about these switches is they'll only fit in the right way around. The actual soldering site for them is slightly rectangular. And because of the hook design on their legs, they'll actually stay in place once you've pushed them into the board. Whilst handling the shaft, I suddenly thought it wasn't as big as I was hoping, and then I found out that I'd picked up an 8mm one, but that's fine. Let's get the switch soldered in. You need to give the switch legs quite a lot of heat because they have quite a bit of thermal mass, but also you don't want to melt the plastic of the switch, so just be a bit careful. And remember, you always want to try and heat the lead of the component and the pad that you're soldering it to at the same time. Failure to heat them evenly means the solder will run unevenly and result in a bad joint. There's nothing worse than a bad joint. Oh fraptious day, Callooh Calais! That's all the soldering done on our A8PicoCart. Actually, I hope this Pico does work. That looks pretty good. Okay, let's program it. Using a USB-C connector, we're going to connect our Pi Pico to our computer. We're going to be using Windows today, but it's a similar process for Linux and Mac. Once connected, your Pi will appear as a removable drive. Inside the removable drive, there's a couple of documents. The first is an HTML document which takes you to the Raspberry Pi Foundation home. All very interesting stuff, but not what we're here for today. And the second document is a text file. I've got file extensions hidden because I've had to reinstall Windows on my computer. And this file just gives some general information about the Raspberry Pi model that we're using. Now I've popped the link below and we're going to head over to Robin's GitHub page and straight into the A8PicoCart project. Robin has provided a wealth of information here, so it's worth reading through if you're intending to build one of these carts. For now, we're just going to download the firmware. It's in a .uf2 format that our Pico is expecting. GitHub can be a bit bewildering to navigate, but as long as you download the raw file you'll be okay. And there it is, 192 kilobytes of pure magic. To program the Pico, all we need to do is drag that file into the root of the drive that appeared earlier. Once it's copied across, the Pico will automatically reboot. And then right before your eyes appears another drive called A8PicoCart. That's pretty swanky. In the root of our new drive, there's a welcome message. Opening the message up, we can see that we are expected to drop our ROM, CAR and XEX files in this root directory. It simply couldn't be any simpler, really, I suppose. So I busy myself copying a couple of games over to our new cartridge. Watching people copy files is pretty boring, so after I copied 3 or 4 games, I looked again at the free space and it's still over 13.5 meg left. That's a huge amount of space for old school games. After ejecting the drive in Windows and then physically unplugging it, we take it over to our Atari. Long-time viewers might recognise this Atari. It was the one which lost its colour. I've got my joystick out and I'm ready to play. Let's see if this thing works. Now, you'd be forgiven for thinking that it goes in the rear port this way, but no, you've got to flip it over, which answers the eternal question, tops or bottoms? I know this Atari works because we fixed it in a previous video, so with great confidence, we flick on the power. Hooray! I actually thought for a second it wasn't going to work, to be honest. But no, winner winner chicken dinner. Let's test this properly, and when I know it's working, we can 3D print a cartridge case. First up is a game that I loved as a kid. My cousin had it on his Atari 400. It is, of course, Caverns of Mars. Caverns of Mars is a classic vertical scrolling shooter game for the Atari 8-bit family. It was developed originally by Greg Christensen and released by Atari in 1981. In the game, players pilot a spaceship through the perilous underground caverns of Mars, dodging obstacles and enemy fire whilst destroying alien installations. The game's unique blend of action and strategy captivated players, me included. And I've still got it. One bugbear I do have is that my reset switch doesn't seem to reset my Atari, but I suspect this is more my Atari. Reset on these machines does rely on a capacitor which may be slightly dried out. I also played a bit of Into the Eagle's Nest, something I remember playing on the Spectrum. It's certainly a lot more colourful. I think if I had graphics like this when I had my first computer, I would have been over the moon. I tested the other games and they worked, but I was being careful not to get sucked off into a fantasy world. So let's sort out that case for our PicoCart. Again, the files are on Robin's GitHub, and it's a really nicely designed cartridge. There's space to fit the USB-C cable into the Pi Pico even when the shell's closed, so you can add and remove games at your leisure. There's also a space for a nameplate. I printed out the one that came with the cartridge, but although it's good and I like the ASCII design, I thought it didn't do the cartridge justice. So I took a little time and I designed my own. Robin mentions on his GitHub page that if you wanted the text to be a different colour, you could insert a pause into the G-code that you sent to your printer. Well, I thought what I'd do is I'd take an Atari 8-bit font and make myself my own logo. And this is the result. I put a pause after the red base and then finished it with yellow. But then I thought, can I go further? And I ended up doing this 4-colour variation with black, red, white and yellow. And it's fairly simple to do. The black base is 0.8 thick and the red elements are 1.2mm thick. By adding pause statements when these layers are hit, you can quickly change the filament from one colour to another. Sure, it's finicky and it's not as convenient as having a 4-colour printer, but it's a pretty nice result, even if it is a bit stringy. and I can clean that up with the scalpel later. I'm going to screw the case together with two M3x14 screws. I actually chose this translucent filament because I know there's an LED on the cart, although it might be quite nice if we can see it glowing through the case. When screwing your case together, remember you are cutting a thread for the first time. Some people like to heat the screws and screw them in, but I think you can overdo that and end up with a screw that's very wonky. Unfortunately, I went a bit mental with the filament choices. I honestly wasn't sure which one I liked the best. In the end, I went with the translucent option. Terry and Dave were impressed anyway. Thank you to Robin for this amazing project. And thanks also to my amazing patrons who are appearing on the screen right now. Honestly, your support means so much. When I sit down and make these videos, I'm thinking about you guys, so thank you. Absolutely empowering and brilliant. If you'd like to become a patron, come along to patreon.com/MarkFixesStuff. You'll get ad-free early access to my videos, there's some behind the scenes stuff, and you'll also gain the ability to run like Sonic the Hedgehog. That might be a lie. Thank you for watching. Perhaps you'd like to watch one of these other videos now. Go on. Why not? It's this or the dishwasher, let's be honest. Bye.